Okay, related rates. All right, so okay, we need you guys focused and paying attention here. These are some of the harder problems you've done all year. All right, so we're going to fill a rectangular tank. So water pours into a fish tank at a rate of 0.3 meters cubed per minute. How fast is the water level rising if the base of the tank is a rectangle 2 by 3 meters? Okay, what was the first thing we said to do? Okay, we already know the size of the shape, right? And this is H. What equation are we going to use? Yeah, volume of a rectangular prism. Okay, what does not change in that problem? Is the height of the water changing? Okay, is the length or the width of the tank changing? No, okay, we can plug those in now. Length times width is 6H. 6, yep. Okay, they're not changing at all, so we can plug them in right now. Now derivative. What's the derivative of that with respect to time? What's the derivative of v with respect to time? Okay, dv dt equals 6. What's the derivative of h? Yeah, 1 dh dt. All right. What do we know? The volume change? All we need to know is the volume. Look at your derivative, Corey. Is there a height in there? Is there a height in the derivative? An h. There's no h. That's what we're looking for. Oh. I guess I'm, never mind. What's 0.3 divided by 6? Is that right?
Oh my God.
Not
Yeah, it's a height, right? They're linear measurements.
that's the change in height.
So it's changing at 0.05 meters per minute. Any questions? This is an easier one. Okay, let's do a conical tank. Okay, water pours into a conical tank, which is the most commonly used shape for tanks above ground. They're cylinders with cones at the bottom for exterior gas stations and such. Water pours into a conical tank of height 10 meters and radius 4 meters at a rate of 6 cubic meters per minute. It's going to be a two-parter. At what rate is the water level rising when the level is 5 meters? These ones make it a little bit more complicated. It still follows the same process though. We have a right triangle here, right? We'll make sure and say it's a cone to be mathematically correct. We need R and H, right? This mini cone is what we're working with. Okay, we know the size of the large tank. How high is the water level? Yeah, height's 5. How are we going to calculate R? Yeah, they're similar triangles. So. Half of 4 is correct too, Ariana. Yeah, this is the surefire way. 20 equals 10R. R is 2. Okay. So we know our numbers. What is dV dt? 6. That's the problem statement. So those are all the numbers we have to work with. Okay, what's my equation? Yeah. Cone volume? Third pi r squared h. It's a cylinder times a third.
So, do we automatically plug in and forward? Or that's not? So always mess that up. Filling our rate 6.30 cubic meters per minute. Original. Fills at 6 cubic volume. Yes, it does. Says it fills at 6 cubic meters per minute. Wrong problem. We're not working on this. We're going in, we're in a completely with completely new data and information. It's one set. It's
How do you know what a
Here's your point.
I'm gonna take you guys somewhere that's gonna show us what we need. What's the derivative of that function? Okay, being aware, this is not gonna work. What we're doing right now, I'm gonna show you what the problem is. Too many variables. So 2r, so 2/3 pi r h dr dt plus 1/3 pi r squared dh dt. No, I'm going to show you why it doesn't work. We have 6, h is 5, r is 2. How many variables do we have left? Okay, we can't solve that because we have 2 variables. So we have to figure out some way to get rid of one of them. Okay?
So we have to find.
We can still use this. Oh, it should be 4/10. Sorry. Right, so R is 0.4 H. Are you with me? We're choosing similar triangles still. Now I'm going to plug that in for R. So V equals 1/3 pi 0.4 H squared times H.
When do we plug in the
After the derivative, because it changes. The R and the H can change, right? So we want to wait. Okay, so there's our equation. Do you have any questions how we generated it? Okay, take the derivative. Go ahead and take the derivative on your own. I want to see if you can do it. If you need help, please ask. Yep. 0.4 squared is 0.16. Because H squared times H. H squared times H.
Oh, yeah.
What's the derivative?
3 times 0.16 over 3 times 5 times 3 squared.
Say that again.
3 times copy of 0.16 over 3 times 5 times t squared.
You're close. The derivative of h cubed is 3h squared. So the h squared still has to remain. Then you put the dh dt.
Why would
Oh,
3 3.
The 3's cancel because you bring a 3 down. Now you can plug everything in. So dv dt is 6, h is 5, and then we can solve. And what do you get? The water level height. Yeah, the water level. That's what you should get. dv dt is 6. We did determine that. There are problems that I don't even try, honestly. If you guys can get these 4 examples I've shown you Friday and today down, you're pretty much in pretty good shape on the multiple choice. Yeah. All right, same homework. Let's see if you can get some work in on it.